Welcome to the Real Python Podcast. This is episode 212. Have you wondered about graph theory and how to start exploring it in Python? What resources and Python libraries can you use to experiment and learn more? This week on the show, former co-host David Amos returns to talk about what he's been up to and share his knowledge about graph theory in Python. David started a Ph.D. program studying mathematics with a focus on graph theory. Though life interrupted his pursuit after 3 years, he is still passionate about the subject. He's been using these skills to create documentation and teach users as part of RelationalAI's education team. David has also been exploring the Julia programming language. He wrote about it on his blog, created videos, and started a podcast on the topic. He shares his excitement about learning new techniques from different languages and how these ideas can enhance your coding in Python. This episode is sponsored by Sentry. Sentry provides end-to-end distributed tracing, enabling developers to identify and debug performance issues and errors across their systems and services. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, David Amos, welcome back.
Yeah, thanks. It's been a little while.
Yeah, it's fantastic to have you on the show again. Well, I just want to start right here. Like, what have you been up to? What have you been doing?
Yeah, I've been working the last couple of years at a company called RelationalAI, gotten all back into the graph theory stuff. I know maybe some long-term listeners out there might remember I have an interest in graph theory.
Yeah,
that's been just a blast to be able to get back into that world and be thinking about those kinds of things. Yeah, been doing that. I've also, my kids have been getting older, so I've been doing a lot more stuff with the kiddos, and they're involved in a lot more activities and everything. My daughter's a competition swimmer, and we've been doing that whole deal. We were in Mexico last week, actually.
Yeah, how did that trip go? We talked offline before this.
Yeah, so she was there for what's called the CCCAN. I forget exactly what it stands for, but it's Central American and Caribbean nations that come together and have a big swim meet.
Okay.
And compete against each other. And she was there representing El Salvador, so her mom is from El Salvador and she's got dual citizenship. And it was great, except that it got interrupted by tropical storm, or I don't know, did it become a hurricane, Alberto?
Oh, okay.
And so they had to kind of pause the meet and kind of do some rearranging of stuff and everything. But yeah, overall it was good. We had a great time hanging out in Monterey, and yeah.
Yeah, cool. That sounds fun. So I wanted to talk a little bit about you kind of did a bit of a programming language journey in between here. And I remember that as you were kind of exiting Real Python there, you were interested in checking out Julia. And it seems like you did quite a deep dive there. So maybe you want to talk about maybe, what is Julia? I know that some people might know that it's part of the name of the Jupyter notebook there. The JU right. is from that. And then I guess maybe we start there. Yeah. So maybe talk about your journey into Julia and what you've been doing with that.
Yeah. So that's a great kind of story. It's interesting. I'd been kind of curious about Julia for a while. I think even while I was working at Real Python, I'd heard about Julia, and I had a friend that was using Julia quite a bit, and he kept bugging me like, "You got to check this language out. You got to check this language out." And I just didn't have time really to to try to learn a new language at that point. And so finally he convinced me, like, just take a look at this and, let me know what you think, and started digging into it. And it's a really cool language. First of all, it's fast. It's really fast, but I found it so easy to pick up. And I think, part of it is I think their tagline is something like walks like Python, runs like C, or something along those lines.
Okay.
Although I will say, the syntax I found, I was drawing more on like my MATLAB experience from way back in the day.
Oh, really?
Yeah, I was finding like trying to like anticipate because I was learning and I wasn't probably using all the resources like I should. I was just kind of like exploring the language and trying to like, oh, I wonder if this works, whatever. Oh, and okay, no, that's a syntax error. Like, what would it be? Trying to kind of anticipate things from a Python mindset didn't work as well as trying to anticipate things from like a MATLAB mindset.
Hmm.
But there were a lot of, similarities. It's a really cool language. The thing that I think got me excited about it the most was not really the speed, although that is cool. And, Python has plenty of ways to sort of get more speed out of it. You can compile to see, like the whole
Yeah.
number stuff and everything.
We talk about the rustification all the time here
Right. Yeah.
of Python. Yeah.
Yeah. And so what I found really cool about Julia was it's literally Julia all the way down until you get to the compilation layer, which is LLVM, I think.
Okay.
But you go into like, compared to something like Python, you go into like NumPy. Let's say you find a bug in NumPy, which is probably not super common for like most people to find a bug there. But
Yeah.
let's say it happens, right? And you just want to try to understand what's going on. You may end up in a world where you have to understand, something other than Python to be able to understand what's going on.
Yeah.
Julia didn't really have that problem. You could just, every layer you would go into is like, oh, it's more Julia, more Julia. And so there was a sense of like, oh, I can really understand things deeply.
Okay.
And I thought that was really cool. They're also their onboarding experience, their first time experience, I found to be really smooth. Just the tooling around getting Julia installed and the tooling around like managing they don't really have environments the same way Python has like virtual environments, but just the way projects are managed and all that kind of stuff is a lot more intuitive.
Do you know the age of the language? Like how long it's been around?
Roughly a decade, a little more than a decade. I think they celebrated their 10 years.
Okay. So it's more modern.
Yeah, exactly. Yeah, no, I mean, and if you ask Julia developers, they'll tell you, they've benefited from, most of them are developers in other languages besides Julia. Some of them come from Python, some of them come from MATLAB and C and C++ and other things. And so they'll tell you, they've relied heavily on drawing from the experiences of other languages. You know what I mean? It's like,
yeah, that's partly why I want to talk about it on the show, because like that is a common theme that I hear from, definitely like the core devs, people like Brett Cannon and Łukasz Lange and people like that. Like I've talked to where they're looking at other languages and they're kind of like, deciding as we migrate and go further into the language, like what do we want our language to be able to do and to approach, and where do you see Julia being used? Is it, you mentioned the MATLAB kind of thing, so that makes me always think of like universities. It's like such a common place that you see those sort of installations of it. But where else do you see Julia being used?
Yeah, so I mean, it's definitely at least when I was more actively thinking or trying to keep up with where it's being used and everything. I think maybe it's changed a little bit, but the biggest group of folks using Julia were definitely like in the academic space, and in science.
Yeah.
And it was in a lot of areas where I saw a lot of stuff like applying machine learning in science and stuff. So those kinds of things. Yeah, I would say that's probably the biggest group of folks that are using Julia. That said, there's also a Julia web framework called Genie, which is, I wouldn't say it's analogous to Django or even Flask. I'm not sure the best way.
Okay.
I'm also not like an expert on it. Maybe kind of like a Streamlit sort of thing, but more powerful.
Like APIs and things like that, or like kind of...
Yeah, it allows you to build like dashboards and stuff really well, but it can do a lot more than that. I know it's a much more full-featured web framework than just something like Streamlit, but kind of targeted towards, you've got some data you need to display and you want to have some interactivity and those kinds of things. And, that kind of stuff. Also, I hope if anyone from Genie happens to listen to this, and I'm doing a terrible job of describing it, I'm sorry, but that's the way I understood it. At least like a year ago. Yeah.
How's the packaging and like the other libraries and stuff like that? I would guess it probably wouldn't be quite as diverse as what's happening with Python.
Not yet, but there was massive velocity. I saw a lot of velocity of new packages coming out and that kind of stuff. So definitely, the ecosystem is trying to get there. And honestly, I think for numerical stuff, my takeaway was I would almost prefer to work in Julia for most numerical stuff that I was kind of interested in than Python. But getting beyond that, it kind of felt like there's just not quite the ecosystem there yet to tackle the stuff, or like the maturity. You know what I mean? Python, the other like big thing that Python has is just the maturity now. The ecosystem has been around for a long time and everything. So that's a hard thing to beat. But
Yeah, cool.
well, and I think that audience, they've been really receptive. I saw a ton of people coming from R,
Yeah.
coming into Julia.
All right. We talk about the cross pollination there from Python and R.
Yeah.
That's interesting too. Yeah.
My feeling was I might have seen more people that were coming from an R background than Python going into Julia, but there were definitely people coming from both backgrounds. Regardless, the other thing that Julia offers is pretty good interop between Python and stuff. So you can actually call Python from inside of Julia. And so
I was wondering about that.
Yeah. And so I don't know. It's definitely something I think if you do a lot of numerical stuff, it's worth considering. Like, just does it have a place somewhere in your pipeline?
Yeah, I wondered about that. Like I've said this many times on the show, how when I got into Python, when I was just starting a job, it was a kind of a cross shop. It was R and Python. And so very often they would come up to me and say, would you like to do this in R? Because that's what it already exists in. And I'd be like, sure. And it kind of made sense because it was like already kind of like a project that was there. But that was probably the hardest thing for me at the time, was like, oh, I know that this thing, like this particular tool, I know what it does in Python. And if I was going to try to run it in R, it was some work. It wasn't an easy task in that sense. And so it's good to hear that, because I think in the data science world, or even mathematical different areas, there is this sort of crossing between boundaries often and having to work with other people and collaborate. But it's interesting, because I try not to be too religious, even though it is the Real Python podcast. I hope people can forgive us to talking about another language. But I always feel like there's lots you can learn about languages and about ecosystems and stuff to pull from there.
Yeah, for sure. No, and I would say that for me, having been so deeply steeped in Python for so many years, it was really refreshing and really beneficial, even as a Python developer, to branch out and just learn a different language, see some different ideas and everything. And I think it impacted some of the way that I think about and write Python. I don't know, like specifics or whatever, but it just, like anything else, it just opens your mind to new ideas and things that then when you're solving problems in other languages, it's a new mindset, a new way to look at things.
New paradigms and things like that.
Yeah, exactly. You find a new solution that you hadn't thought of before. So,
yeah. So you did a podcast for a little while.
I did, yeah.
Talk Julia. And I found that really interesting because I think that helped you maybe land the job. I'm not sure how that kind of got connected together.
It connected me to RelationalAI. Yeah, so I definitely need to bring up the podcast. So that was kind of my way of learning. Julia was...
Yeah. It's a great way to learn. I definitely do it here.
And the co-host on me with that, Randy Davila. So I have known Randy since college. We met, both of us graduated from the University of Houston downtown. So he was the one that was bugging me for years. You got to check this language out. You got to check it out.
Okay.
And so he was kind of ahead of me, knew a little bit more about it and everything. And I was just kind of, trying to learn it as we were doing the podcast and everything.
Yeah.
That was a lot of fun, a lot of work, mainly because we decided to do the video route, and the video editing was just so much work. I
haven't quite done that yet.
That ultimately, I think, that and a combination of then getting the job at RelationalAI kind of, led to the end of the podcast, and we're not doing that anymore. But kind of that story there, I don't think it got me the job. I don't know that I would put it that way, but it connected me with the people at RelationalAI. So one of the early guests, actually, I think he was the very first guest we ever had on the podcast, a guy named Logan Kilpatrick, was kind of like the community manager, or I'm not sure what exactly his title was or whatever, for the Julia language. So he was working with the group, that develops the language, and just kind of managing social media and the Discuss forums and, that kind of stuff.
Yeah.
We had him on to talk about the language and stuff like that. And a couple weeks after that, he invited me to a Twitter space. That's what they were called, right? Spaces.
Yeah.
Do they still have those? I don't know.
This is at the time they were doing Clubhouse, and they were kind of making a competitor of it.
Yeah, exactly. So this would have been 2022, maybe, or 20. Yeah, I think 2022.
Sounds about right. Yeah.
So he invited me to the space. They were talking about getting a job using Julia. And I mean, I wasn't interested in a job as a Julia developer, but as the host of a podcast, it was like, I should probably go, and maybe there's some companies, to invite and stuff like that. So we go, and Molham, the CEO of RelationalAI, was one of the guest speakers, and he spoke about what they were doing. And if I'm completely honest, at the time, I wasn't 100% sure what they were doing, but
you've learned a lot more since then.
Well, yeah, but he kept mentioning graphs, and I was like, I've got to go, figure this out. So I went to their website and kind of got some more information and everything, and it was like, this looks really interesting, kind of up my alley. So I applied, and now here I am 2 years later, and it's been a really cool journey. In fact, it's brought a lot of things together. So there's Julia involved in RelationalAI.
Yeah.
However, our product, the interface for our product is all in Python. So, kind of brought both of those worlds together in a way. Although my, day in and day out, I don't really work with Julia much at all. But so there's some cool stuff to talk about there. And then also just the graph and graph theory side of it. So it was like, I don't know, it just felt like, man, this is
that's a cool fit.
Really cool fit. Yeah.
And you've been doing a lot of writing too, right? Which is, kind of your background from Real Python.
That is my role. Yeah. So I'm a technical writer is my official position at RelationalAI. And currently I'm kind of managing all the documentation, not all of it. And lots of writing.
Yeah, cool. yeah, definitely. Sentry provides end-to-end distributed tracing, enabling developers to identify and debug performance issues and errors across their systems and services. Their tracing offering focuses on proactive debugging rather than passive observability. It introduces a span-based tracing model, allowing developers to track the complete end-to-end path of requests, pinpointing issues across distributed systems and microservices. With the Trace Explorer, users can search specific traces using high cardinality data and debug efficiently with full context in the redesigned trace view, which provides detailed visibility of application requests and metrics. This approach helps identify and resolve performance bottlenecks quickly. Installing Sentry is simple, like 5 lines of code simple. Use the code REALPython during signup, and new users get 3 free months of the team plan. So when your code breaks, you can fix it fast. I've wanted to talk to somebody about graph theory for a long time, and you had mentioned it and brought it up, I don't know how many times back when we were doing the show together and pulling up articles. You're like, oh, I'm fascinated in this. And so I was like, okay, that's David's thing. He's going to go to town and so forth. And so I didn't really dig much into it. And so I think most people know that I did not go to school for Python or for, programming. Like my school days were a long time ago. And I was at the time, looking at like electrical engineering. And so I was touching on Fortran and C and so forth. So I learned some fundamental concepts, but I didn't really, a lot of these things are new-ish comparatively. And so maybe the first question is, did you study graph theory in school at all?
I did, yeah. So I almost got a PhD in graph theory.
Okay. See, you're the right person.
I left, in graph theory, right? I mean, it would have been in mathematics, but I mean, I was focusing on using graphs and solving problems and stuff. So I did not finish my PhD. I ended up leaving to go into industry. I had a family and just PhD stipend was not cutting it. And I had to...
It's hard, yeah.
Had to make a decision. And anyway, it worked out great for me. So in the long run. Yeah, so I studied graphs. I have a lot of background academically thinking about graphs and everything.
Yeah.
This is a different situation where now we're trying to apply graphs to business problems.
Yeah.
But the people that are running into those problems and tasked with solving them know nothing about graphs or really have a limited knowledge about graphs.
So you're explaining them a lot, and through the documentation that helps, I guess, too. So
not quite yet. Our docs don't have a lot of explanation. We're finding that to be the case. So we may end up, having to do a lot more teaching of that. But there is kind of this gulf that exists in this world of people have been talking about using graphs for quite some time. We have like graph databases and everything.
Right.
And some of them are really great and they've, had a lot of success. But one of the big issues that you constantly run into is people say, I've got this data. I see this cool stuff that people want to do with graphs. I just cannot figure out like how do I do that with my data? What, and the issue is that graphs are an amazing tool that help you solve countless problems.
Okay.
Like it's such a general framework for representing a problem and then, doing algorithms on something. The issue is to get any real benefit from it, you have to really have a good understanding, not only of the domain of the problem, but also the graph background. So you need sort of like a domain expert who's also a graph expert, which is like a really tough combination to find. There are people out there like that.
Yeah.
But really, you want some kind of, you'd hope that, you could make graphs approachable and everything. And so, yeah, that's still kind of an open question. I think like we're working on tools to help make that easier for business folks to approach those problems. Right now, we have more of a low level kind of API to graph tasks and everything. But yeah, just to, I guess, maybe to kind of back up a little bit and just explain like what is a graph. Maybe some people, I think if you're a programmer, you may have, at least if you've been doing it long enough, you may have some notion of what a graph is, because it's a data structure that eventually I think comes up if you do certain kinds of tasks in programming.
Yeah.
But it's just a general idea. I think, that's one of the things that makes graphs a little bit challenging is like there's just this general notion of I have some set of objects and those objects have a relationship with each other.
Yeah.
And so visually, you just think of drawing a bunch of dots on a page as these are all the objects that you're kind of considering. And if there's a relationship between two of them, you draw a line and connect them. And so we call the dots nodes and we call the lines edges. And that's what you hear people talking about, nodes of a graph.
I think edge is such a weird term to use for it, in my opinion, because anybody thinking of geometry or whatever, you think of that always being like that's the edge. That's as far as we can go. You're not going to go beyond it.
And this is a great point, and it's something. So if you look in academic literature, they don't call the dots nodes; they call them vertices, which makes it even more confusing because you think vertices and edges. Now you're like, what are these, like polygons or something? And so
exactly.
That's actually a really good point, because it can be confusing. Graphs they're not geometric in the sense that like you can draw them a particular way, right? You could, and that's one way of drawing them. And then you could sort of shuffle things around. And as long as you keep the connections the same, you can move things around as much as you want. And that's the same graph. Like you haven't changed anything. So there's no like geometry involved with them. It's just connections.
Which is interesting to think about. The one that I think maybe most people would be familiar with is social networks. Like the idea that that's where I started to hear about this idea, the quote unquote social graph, that like I join something like, I don't know, let's say LinkedIn. And so I have this group of people that I friend or connect to that are, people that I worked at this one particular job. And so I have these like sort of connections there. And those people have their connections from that same job. And then of course people move on to another job. And then they start developing this other tree from there. Whereas like maybe a simpler one would be like, like a Facebook thing, which is kind of a friends and family kind of set of graphs, which are interesting. And so there were like these startups and stuff that would try to jumpstart their social graphs by, well, let us get your contact database. Would that be okay? Like, let's have access to your contacts. And you're like, oh, okay. Or, and so suddenly they've imported all this stuff in and they can go, oh, it looks like this person knows this person, and you might be friends with this person. Do you want to add them to your whatever friends list and so forth? And so there's like all these, like you said, individual nodes, people in the case of those things. And then the edges are all the different types of connections you might have. And the types of the relationships may be different. And I don't know if that's something that's defined in graph theory also.
It is, yeah.
Yeah, okay. So like, I don't know if you want to jump from there, but that's the one that I can think of. And then I know there's other ones, like we talk about, I had Calvin Hendricks Parker on recently to talk about RAG and the idea of augmenting LLMs by adding additional information. And so this idea that you have to vectorize, quote unquote, this data that you have. And so then it has to build all these relations between the words and the concepts in the documents that you have there, and you use a tool like something like ChromaDB that can have a database that's designed like that, that understands the idea of, maybe a little bit more than a standard relational database. I think a relational database is a little, I want to call it crude, but it's maybe missing some of the tools. And
Yeah.
maybe we can talk about that, like what's different in the types of databases there.
Yeah, absolutely.
Yeah.
So, I mean, I think there's a couple of questions, right? So,
yeah, I think I threw about 5 at you. I'm sorry.
That's all right. I mean, so I definitely want to get to the last one about the relational databases and everything. That's an important topic. But just to maybe talk a little bit more about graphs and so the idea of a social network and everything, that is kind of a classic example of a graph. And you see that all the time in intro articles about, thinking about graphs, because that's something, it's not only a graph that we belong in, everyone kind of, is in some kind of social network, but it's one that we actually use every day. If you use social media, you're actively traversing a graph, basically, when you're clicking on profiles and stuff to go see and everything. And then
who gets shown different things and
exactly,
all that sort of stuff. Yeah.
But that's just one way to build a graph of people, to give you an idea of how general the notion is, and maybe why it can be challenging to figure out how to apply graphs to this. Because the idea is, once you have a graph, then you do something with it. The graph itself doesn't really answer anything. It's more of just a tool that, now that you've got it, you can do some kind of algorithm on the graph to answer some kind of question.
Okay.
But if the graph isn't set up properly, if you don't have the right objects and the right connections, you may not be able to get the answer to your question. So it's not okay, I've got a social graph, I've got, here's the people, and these are the edges. But let's say it's LinkedIn, where you can follow someone, which is a directional, you follow someone, they don't necessarily follow you back. But then you can also connect with someone, which is a mutual thing, where you both connect with each other and you establish a connection right between both people.
Yeah.
So,
which I think it was always sort of the Facebook kind of model, is this is agreed that, we are connecting together. Whereas the following was kind of a Twitter thing. So it's weird that to have a network like LinkedIn where it's both.
Yeah, exactly.
Yeah.
So, that's one sort of distinction. There's different kinds of edges that can be directed, right? They can go from one node to another, but not necessarily in the opposite direction, or they can be undirected, where it's just it's a connection that goes both ways.
Okay.
And then in addition to that, you can think of okay, if I've got a graph of, say, the LinkedIn network, and I know this person A follows person B, and then I've got other types of edges that are connections that aren't directed and everything. Depending on what you're trying to answer, that may not be the right graph. And then also, you may not have that information. So let's say your business, I'll give the example. So I can't claim responsibility for this example. This comes from a demo that was developed by some people at RelationalAI and some people at Snowflake, which is our partner, where when we talk more about RelationalAI, you use it in conjunction with Snowflake, but we'll get there. So the example is, they call it their Tasty Bites example. And it's basically a fleet of food trucks in San Francisco, I guess, or some city.
Okay.
And it's a fictional business, right? They manage all these food trucks and everything. This example they gave was, you've got a food truck that's been serving cold burritos, and now people are complaining on social media about these cold burritos and everything. And you're trying to put this fire out. You want to try to figure out, you can figure out maybe who the people are that got served a cold burrito, because you can just look at orders at that food truck, right? You've got that information. So, okay, the people who got served a cold burrito, you can send them a coupon for a free burrito or something. Say, we're sorry you had a bad experience, whatever you want to do. But those people are going to talk to other people, right? Their friends and everything, and say, hey, this food truck really sucks. I got served a cold burrito. Don't go there. So the idea is, maybe you want to try to get ahead of that and try to figure out, do we know any of their friends? Can we sort of preempt that and send a free coupon to their friends as well?
Right.
But you don't.
Can we make sure we hit the community with this stuff?
Yeah, but you don't have their data, their social network data. You don't know who their friends are. All you have is customer order data. But there are ways you can sort of infer, well, we might be able to figure out, maybe we don't know that they're friends, but we know that they maybe know each other. Maybe they're coworkers or acquaintances or something, because maybe we've seen that they have come and eaten together at the same food truck. They've both purchased something at the same food truck within a short period of time, multiple times over the last year. Like maybe they've done it 4 or 5 times over the last year or something. And so we don't know for sure, right? You just
Okay.
flag, okay, there's a couple of transactions that are within, say, like 20 minutes apart from each other. These two people and the same people we find that same pattern at the same food truck with the same people like multiple times throughout the year. We're going to guess that they might know each other. And so what you're doing is you build a graph now where the nodes are the people, still your customers, but the edges are like, maybe know each other based on the data that you've got just from, orders and everything. So you can build up a graph of like a, potential social network. You can't verify it or, whatever, but it's a decent sort of proxy
Right.
for all of that. And so even you don't have all that data, you can still kind of infer some of that stuff, which is maybe kind of weird, right? Like it's makes you wonder about like what else can you infer, from that kind of stuff. But it goes to show you that even if you say like, oh, I don't have a social graph, well, you don't necessarily need a social graph to be able to answer questions. You can sort of build a proxy to that, which is still a graph, but it's just based on kind of what you do know. You can come up with some good rules to help you make those decisions and everything. And then you can still get a solution to the problem. Now, it may not be the best, like perfect, like you nailed it, you got everyone's friends. But, at the same time, it's like, okay, well, we sent some wrong people a free coupon, whatever. Maybe they'll come and still get a burrito and eat there some more. But
yeah, can I ask a question on the database side? Like, I'm so accustomed to standard relational database tables and so forth. And so I think of like columns, and I think of these types of pieces of data that would be in quote unquote a row. And I feel like this is not structurally the same. Like you're not looking at a node and the edges that are attached to it the same way. Like I don't understand how that stuff's stored. Like,
yeah.
Like, do we have to have a completely different paradigm, or is it the same?
Yeah, so that's a really good question. Traditionally, you've switched into a different paradigm. So you've got data that's in the relational format. Like you have a table of customers, right? And you've got customer ID, their name,
Right.
and other information about them that you know, right?
Yeah, phone number, address, blah blah blah.
Yeah, that's not in a graph format. Like you don't have a way to know that like, oh, these two customers are related to each other. And so traditionally what you've done is you've exported that data, you've turned it into a graph data structure that has the right tools for managing the connections and that kind of stuff, whether that's putting it into a graph database, of which there are several, or it's just doing it in memory, right? If it'll fit with, there's something like NetworkX is a Python package that can do graphs, in memory and those kinds of things. So
yeah, okay. I've heard of that one, yeah.
And so that's kind of the traditional route. And honestly, if you have something that fits in memory, I mean, NetworkX is probably the best tool for that. If you're in the Python land, like it'd be hard to beat, something like that if it has the tools you need. So you might do that. But the other kind of issue with all of that is in order to get it into the right format, you may have to move data out of your database somewhere else. And this job at RelationalAI is the first time I've really been exposed to like the enterprise world of data and everything. So much was like
quote unquote large data, big data, whatever you want to call it.
And it was kind of like a culture shock at first to me of like how big of an issue this actually is for people. And in some cases it's because of the size of the data, right? It's just I have too much data to move. In some cases, even if you could move it easily, it's not the size of the data that matters. It's related to ideas of security and governance of data. And like this data,
sure,
there are regulations that say that I cannot move this data. Like I have to do it here, right? And so,
right,
all these issues kind of crop up when you start to try to apply this stuff to like an enterprise level where you've got massive amounts of data, or you've got regulations that say it has to only be in certain places or things like that. It can't, and it's like, okay, well, if we do want to move it, now we've got to start a whole process of getting things approved and all this stuff.
I did a little bit of compliance for just a short while, and so like filling out vendor management forms and answering every single question inside there to say, this is what they do, this is the software that they use, this is how they're connected, and it's just very, very, very detailed. And there are fields where that is required. You have to have done all that, and I can imagine that's a huge part of quote unquote enterprises,
Yeah. Well, I mean, anyone that's handling medical or financial data, I mean, there's just all sorts of stuff they have to keep in mind. And yeah, it's really difficult. And people, for good reasons, take that really seriously. And it kills projects. I mean, there's things that you look at, it's like, there's a great off the shelf solution for some of this stuff. And it's like, well, it would be too expensive to go through the process of getting all this stuff approved. Like, we're just not going to do it. This is becoming more and more of an issue with the rise of like all this AI stuff and everything, right? I mean, companies are feeling massive amounts of pressure to try to provide something, but then like they're running into like these kinds of issues, right? Like I can't just send my data to OpenAI. Like that's not really an option for me. I need something in house or something. So yeah, all these kinds of issues. And then going back to like the relational database idea is like, okay, I've got all this data already. It's in a relational database that is kind of just the standard format, right? And if you're an enterprise, you're on a data cloud somewhere. You're either on Google or Snowflake or Azure or things like that. Again, it's all you've got most of it's in relational databases. And you can use relational databases to represent graphs pretty easily, although you have to kind of switch your thinking from nodes and edges to relations, right? Like just tables of rows or just tuples, even if you want to think of it that way.
Okay.
You could represent a graph as nodes are just a single columned table, right? Like that's my set of nodes. And then I could have a table that just has two columns where I have like a from column and a to that has the ID of the node and that it's going to in the table.
It's a sort of connecting table that that is looking at these other quote unquote relational databases, but this particular new table that we've added is all about the connections. It's all about the graphs.
Yeah, exactly. Okay. Yeah. And so you don't even necessarily need, like I said, a single column for the nodes. It could just be like your existing customer table. That's like, okay, where the node information comes from. And then you have this edge table that connects them with like two columns, right, just using their IDs or something.
Yeah.
Now, so that helps you represent a graph in a relational database. But then how do you do stuff with it, right? Like all you have, if you want to do something in the database with it, you have to use SQL. And SQL is going to struggle with a lot of graphy kind of operations. It's just not optimized for that. It isn't going to work. But I've seen some amazing SQL through the course of the last couple of years of people doing some of these graph things. And it's like, you see it, you're like, wow, okay, they proved it's possible. But like, who in their right mind is ever going to write anything like this? Like no one.
Melts your brain.
Yeah, exactly. It's not, not good. And so if you want to be able to do something directly with the data in the database and not have to, move anything around, then you need a system that can work with relational databases. And that's where RelationalAI kind of comes in. That's a whole thing, the relational part in the name. So we have, before I joined the company, there was a group of researchers that had done a ton of work on new kinds of joins and all this kind of stuff. I'm not the right person to talk about all the details, and I'm not sure. I don't know that the real Python audience would necessarily want to get into all those details either. But it's real, database theory heavy and everything. But they came up with some novel ways to do joins and things like that, where you could now tackle these kinds of problems just in a relational database. And we've put together a Python API that can access the database and everything, and then run the different operations you want to do with it and everything. So it provides a way. Right now, it only works on Snowflake, the Snowflake data cloud.
Yeah.
And we've partnered with them, and that's kind of that's where we live. And if you use Snowflake, then they have this new feature called native apps, which they announced. Well, I think they announced it like a year ago. It's now available. They've announced the availability of it, but they're a couple of weeks ago in their big summit that they did. And so where we have the RelationalAI native app that you install, people can start running graph algorithms and doing stuff like that on their data.
Yeah, you were telling me before how it kind of connects to this Snowflake instance. So again, going beyond this idea that we've mentioned several times of like, we not only do not want to move our data, we by compliance reasons can't or should not do this. And so the idea that it can be in place and then this tool can kind of connect to it and do the relational stuff on top of it and kind of give you that sort of functionality which is kind of neat. I think that might be a model that is definitely forward thinking. You know, a lot of people in this field are looking at all these different like types of tools, and I don't know how many times I heard of like, take all our data and let's put it in a big data lake and move it over here and that sort of stuff. It's like there's only so many times you're going to go through that process of moving the data again, I think.
Yeah, for sure. I mean, it's so much pain that, it's not something companies want to do very often. And on top of that, it's interesting. It requires a lot more than just something like relational AI at this stage. So there's been a ton of work on Snowflake's part to provide, what they're doing is it's called Snowpark Container Services, and it allows you to run application and containerized applications in your Snowflake account within their whole security perimeter. So you can actually run all sorts of stuff in there, like anything that you can put in a container and run it. And that's how we're doing. So we have our service that's running as a container in Snowpark Container Services that's like installed in the Snowflake account, and then it's all being spun up all within that that security perimeter and everything. What we're doing is we're attaching to the data so that the data never has to move outside of Snowflake, but then all the actual compute and the processing and all of that is happening in our application, but it's all in your account. Everything is just running inside there. And yeah, it's a model, it's a platform for building applications literally on top of the data without having to move data anywhere else. You don't need an application database at all. You just kind of the single source of truth. So yeah, I think it's all in, service of moving towards this picture of your data is just in one spot always.
Yeah.
And then everything else just kind of connects to it, or connects to, views that have been prepared for that application and things like that.
Yeah. Okay. Yeah. That whole bit of a warehouse kind of
Right.
formatting kind of thing, potentially. Yeah. Okay. Yeah. Cool. So you mentioned Network X as a potential tool that maybe people could explore if they're interested in diving a little deeper into graph theory, using Python. I mentioned ChromaDB because I know that one's really popular, especially with tools like RAG and so forth. And I'll link to some resources from Real Python that talk a little bit about vectorizing things. But is that part of the process of what you're doing? I use the term vectorizing. I know that the relations may be very different depending on what people want to do with like a tool that you guys have. We talked so much about people and the relationships there, but is it just a matter of like sort of changing like, okay, well, what are the relationships that we're trying to set up? It could be, I guess, events that could have happened that you want to look at, the graph there, or we think of, again, vectorizing language into large language stuff. So you see all the connections, like, again, the common thing of people saying, it's just selecting the next appropriate word, or whatever. Is that part of that? Is that, I guess I'm trying to formulate a good question for it.
I think I know what you're getting at, and I think I can provide an answer. So we've talked a lot about graphs and everything, and that's a big part of relational AI and what our tool does. But to talk a little bit more specifically about what it is that we do, and to give you an idea. So the main concept in our tool is called a model.
Okay.
We have a Python package that you install called RelationalAI, and that's on PyPI. You can just pip install it. You are required to have a Snowflake account to actually be able to do anything with it. So if you're just a single developer, it might be a bit of a challenge to get into something like that. But that's all right. I mean, our target audience is for people who are on Snowflake. So
yeah.
But the main concept is a model. So when you install our Python package, you do import relational AI as RAI. That's what we call RAI is how we pronounce it. And then you just do RAI.model, capital M. It's a class, and you give it a name, and you get this model object back.
Okay.
What you're able to do with the model is the way we think of a model is it's composed of three things. It has objects, which are like the nodes in the graph. We just call them objects because they're just kind of a general, it can be anything.
Yeah, sure.
Objects, it has types, which are sort of collections of objects. So you can sort of categorize objects by type. And then objects can live in multiple types. So you can use a type, for example, like if you have a person, you could say, okay, this is an object of type person, but that person has age 18 or older. So I also have a type called adult that's going to hold all the people who are 18 or older in this adult type.
Yeah.
Whatever. So you have things like that.
Okay. Categorizations, yeah, across the board.
Categorization, yeah, kind of lets you build a hierarchy and everything.
Okay.
And then you have rules. And rules, that's really the key thing here. So by having objects and types, actually there's one thing I should mention before I get into rules, is objects have properties. And you can think of this like a Python object. In fact, that's actually very much the way we want you to think about objects in the model, as if they were just kind of Python objects. And so they can have properties that you can have, object.name, right? If it's a person object, and that's a name property.
Right.
And so what we're doing is we're transforming in our container that's running in Snowflake. You can point to specific tables that you have in Snowflake and say, I want to import these tables as objects in my model.
Okay.
And it'll pull everything in. And what's going on is we basically create like a graph index over that data. So it's still a relational index, but that's what we're sort of storing in the container that's running in your account. So we've got this graph index now of all the data, and then you can add rules into it. I should say, when we have by graph index, you can think of it as we're basically setting everything up into this, the way we talked about, where you've got these tables of just pairs of like, these are my edges, defining my edges and my relationships and everything. And then indexing it all and everything to make it fast and stuff to access. So that's kind of what's going on there. And then you can add rules to the model. So this is what kind of makes it unique in sort of the graph world. So by having objects and properties and everything, you kind of already have a graph structure because properties don't have to just be values. Properties can point to other objects. So you can have a property that's basically like an edge in the graph. It's just saying, this property connects, objects with this together. And what rules allow you to do is sort of put constraints on the graph and build new edges and things like that on top of it to expand the graph without having to do everything manually. So you can have a rule that just says, give me all objects of type person, check that they have an age property that's greater than or equal to 18, and set the adult type on them, right? And that just becomes a rule in your graph. And then, or in the model, I should say. We really want to use the word model. Because the idea is that we don't want you necessarily having to think in terms of graphs. We want you to be able to think in terms of just objects and properties,
right?
Which are already,
and modeling what all that stuff is.
Yeah, exactly. Right? And so the graph stuff is kind of happening in the background for you in terms of like, that structure and everything.
Okay.
And so rules are really powerful because they let you express sort of like the model of your business, the rules that sort of define like the way things are or supposed to be in the business, or, certain decisions that have to get made or things like that. And then you just import the data, or just run, or we call it running the model, executing the model on top of the data. If the underlying data changes, the model, the rules, the model, everything, it just, everything gets sucked up and pulled in the way it's supposed to into the model.
Okay.
So there's kind of this continuous connection, I guess, between the data and everything. Like every time you run your models, you can add new rules, you can do all this stuff, whatever the underlying data is. That's what gets used automatically.
Okay. It's just dynamically updating as it goes and so forth. And so if you modify the rules, it'll update all the values from there, or you add new entries into the database or modify things there, it'll update as it goes. Yeah, that makes sense to me. Yeah.
Yeah. And so all this is done when it gets requested, right? So it's not everything is happening always in the background. There are ways to control some of that kind of stuff, but keeping things maintained in the background could be expensive, depends on, so you can turn that off and everything. But yeah, at a basic level, every time you run it, it's always pulling in the latest data. But that's not a super expensive operation because of kind of the deep integration that we have with Snowflake. The data is not leaving anything, right? Like, yeah.
We talk about that a lot, the whole idea of egress and ingress and like that whole like process of transforming all the time, and the idea of it being in place, that seems to be a nice change. So
yeah.
This week, I want to shine a spotlight on another Real Python video course. In programming, the term constant refers to names representing values that don't change during a program's execution. Constants are a fundamental concept in programming, and Python developers use them in many cases. But without a dedicated syntax for defining constants, what are the best practices for working and creating constants in your Python code? This course is titled Defining Python Constants for Code Maintainability, and it's based on a real Python article by Leodanis Pozo Ramos. Your instructor for the video course is Darren Jones, and he shows you how to properly define constants in Python, identify some of the constants that are built into Python, use constants to improve your code's readability, reusability, and maintainability, apply different approaches to organize and manage constants in a project, and use several techniques to make constants strictly constant in Python. Like most of the video courses on Real Python, the course is broken into easily consumable sections, and where needed, include code samples for the techniques shown. All of our course lessons feature a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. Do you have other suggestions, like Python libraries people could check out to learn a little more about this sort of stuff? I don't know if there are other places that you used as resources to learn a little more about this.
Yeah, I mean, I think NetworkX, if you want to get started with graphs in Python and explore graph theory, NetworkX is the right place to start because you can just get a CSV file on your computer and, start doing stuff with it. Now, it's not going to automatically put things into graph format and like all that kind of, right? Like you have to do more low-level work. We have a lot of tooling in place in our package that does interesting stuff with the data and everything. But I mean, it allows you to get started if you don't have access to Snowflake or anything like that.
Yeah.
And is a good place to learn. I mean, if you're really interested in learning more about graphs, the best book that I can recommend, and I think it's one of the best resources just for anyone, even if you have kind of a math background, although it's not maybe quite at the level if you're at like a high level math, it may not entertain you as much, but like it's a great like layman's resource if you're willing to do just a little bit of math. So if you have like a solid high school math background, I think you'd be able to approach this book. And it's just called Introduction to Graph Theory by, I think it's Richard Trudeau.
Okay.
I know the Trudeau part is right. I'll have to pull it up and look at it. But he gives one of the best intros into graph thinking that I've seen. And that's so important for these kinds of problems. The issue is like, so he presents all these different problems in the first chapter that you might not think about, like trying to figure out where to place security guards in like an art gallery, or trying to figure out like how many light cycles you need in like a stoplight at an intersection.
Okay. Optimization
kinds of things and stuff that you may not, like on the surface, you'd think like, whoa, how is a graph actually going to help me there? And having him walk you through or sort of, show you the way you build the graph for those kinds of problems really helps you start to see graphs everywhere, which is
the point.
Well, it is the point, but it's so I don't want to make it sound scary or anything. I mean, graphs are amazing and graphs are super cool.
No.
But it's one of the reasons I'm so excited to work at RelationalAI too, is that they really have this vision for trying to make these things more approachable. And there's a great article I read by his name's Hillel Wayne, who shared an article about like the problem with graphs or something. I can't remember the exact title. I don't think it was that. So, but it was, kind of focusing on this issue of like graphs are super powerful. People want to use them, but they're really hard for the business person to apply to a problem.
Yeah.
And so, I'm really looking forward to, seeing what we come up with to try to help with that problem and everything.
That's cool.
But that book is a great resource.
Yeah, I'll have to get that article from you if you can find it. So yeah, we can put it in the show notes.
Yeah, I'll look it up and send it to you for sure. NetworkX is a great place to start. And if you're interested in doing anything with Julia, there's also a Julia Graphs, which is kind of the Julia version of NetworkX. So it'd be kind of maybe fun to look at both of those and compare.
Yeah, cool. So you're here and you get to go through my usual recurring questions here. So what's something that you're excited about that's happening in the world of Python right now?
Yeah, that's a good question. I haven't been as plugged into the world of Python lately. Something that maybe I'll just say what I hope to see. And I know I understand this is an incredibly difficult problem because of the history and everything, but just the first time experience for new Python users. It's been interesting. Like even working at RelationalAI, I end up having to help with, people like trying to use our product and they don't have Python installed. They're not really Python people necessarily. And it's just it's hard sometimes to watch people go through all that and everything. And so I know that there's been some, especially like around package management and the virtual environments and everything. And I would love to see some kind of in-house solution for that. I know there's all sorts of, use Anaconda or go.
They've been working a little bit on it. Yeah, they actually, there's some changes in the upcoming one for a handful of things. And one thing they've changed is the built-in REPL. They've added a bunch of new kind of functionality there. So I feel like there are people looking at it. And I think by having more and more people that have been hired by the Python Software Foundation to work on this stuff,
yeah,
I think that may be around the corner, honestly, because it feels like they're solving a lot of it. I still, as much as there's so much stuff out there about, oh, you could use, this tool or that tool or whatever, it's like, man, just go to python.org to install Python. You're going to get everything that it normally comes with.
Yeah, exactly.
The one maybe caveat would be if you're on Windows, depending on things that you want to do, you might look at that Windows subsystem for Linux kind of thing. But outside of that, that's definitely a place I go. And I hope it gets better. But I agree. And I think the packaging thing is getting better too. It's been interesting watching that fly by over the last couple of years. Yeah.
It seemed like kind of towards the end, like when I was still working with like the PyCoders newsletter and things like that.
Yeah.
It seemed like there was a lot of sort of movement in that direction, or at least a lot of energy building in that direction, that would result in some movement. So yeah, I'm glad to see that. I understand too. It's like, it's a hard problem to solve.
And the history too. We talked about that, right?
Yeah, exactly. Like, I'm not like, I don't want to rag on anyone because I get that, like, yeah, that's it's got to be done right. And at this point, that's really hard to even tell like what right necessarily is. So yeah, I get it. I will say I saw recently where there's a second developer in residence position. Is that true?
Third too.
There's a third now too.
Yeah. So there's two primary people and then another person that's sort of underneath them. And so there's three people that are pretty actively working on stuff. And then I've mentioned a couple times and had one of the people that are involved in the security side that is now a full-time job too. So it's like kind of what's happening with the Python package index and just generally looking at these things. And so it's good. It's really, it's nice to see, and it's nice to see. I hope this keeps going, that, these large corporations who use these tools, without any kind of necessarily, remuneration for, doing it and so forth, that they can look at least sending some money toward, keeping the development of Python and the tool architecture and the package index and things like that.
Yeah.
Keeping everything running and smooth and so it's looking good.
I would say then that's my answer to your question, that the fact that there's now 3/4, maybe even full-time developers, that's awesome. That's super cool.
What's something that you want to learn next? Again, this doesn't have to be programming.
Yeah, that's so non-programming related. I have sort of gotten into gardening a little bit.
All right.
And that's something I would like to try to learn more about if I can find the time to actually do it.
Yeah.
Other than that,
you got a pretty wet climate there, right? I mean, at least it's humid.
It's very humid. Yeah, I'm in Houston, Texas. Yeah, it's like 1,000% humidity all the time.
That's how it works. Yeah. I don't know if that affects like the types of things that can grow, and like, where are you starting? What types of plants you thinking of doing?
So the only thing I've had major success with is peppers.
Okay.
Chili peppers, and then also like sweet peppers. So I've got like 6 different kinds of peppers right now in my garden.
Sure.
I've done some okra, which has done well here. I don't know. Most everything else I've tried has not been successful.
I don't know if I've ever mentioned this, but when we were in Hawaii, I had this kind of interesting spot of our backyard that was sort of terraced off and couldn't really make it a lawn or anything like that. And so I decided to do a garden back there, and I tried all kinds of different stuff. And the problem is that it would either grow too fast or not grow at all. And so like my real successes is I had actual banana trees on the side of the house, which is really cool. They're fascinating plant, the way that they grow, and the main, tree sort of dies off, but there are these little they call them cakey little kids version, of that grow like next to them and then go up from there. But it's weird as a harvest thing. You're like, I have so many bananas now. So suddenly you're like having to like, bother your neighbors or whatever. And they were like these little small ones, the little,
I gotcha.
I think they call them like candy apple ones is what they probably call them here. But there it's, just, they're the bananas that you get from Hawaii. But so that was fun. And then we had a papaya tree. That was very interesting too. So, but yeah.
Yeah. I think, you have to like actually pay attention to it. So that's what I struggle with. I just got a lot going on.
Too. Yeah.
Yeah.
Got to set the reminders for the garden. Yeah. We talked a little bit about social networks earlier. I don't know if there are many ways that people can follow the work that you're doing online. We've mentioned, obviously, your work at RelationalAI, but other ways that people can follow you?
Yeah. So I've not been doing a whole lot on social media over the last year or so, but I do still have a Mastodon. It's at the Hachyderm IO, and it's just SOMACDIV, or no, DAV. It's my name backwards. David C. Amos backwards. Somac Divad. I don't know. You can probably search for David Amos and find me. I'm also on LinkedIn still, and I also have a Medium profile, and I've been thinking about trying to do some more writing on Medium maybe. So
yeah. Is your stuff still up there?
Yeah, all the stuff is still on Medium. Yep. Kind of all my old stuff that used to be. I got rid of my personal website. I had like a moment where I was like, I need to just focus on like two things: work and family, and exclude everything else. And
makes sense. Yeah, I was thinking about as a potential topic of like avoiding burnout, and we didn't really go there today, but that's definitely one of those things that you can kind of overextend yourself, especially if you're in between jobs or trying different things or just, trying to see what you can do. It's really easy to do. So I feel like you kind of went through a little bit of that yourself.
Yeah, I did. And I just needed, my kids, like I said, my kids are getting older. My oldest daughter is almost ready to go to college, which is like so insane to even think about. And there was just a lot where it was like, I just need to be more present and for a lot of things. And it's really helped. I don't know. I would, anyone who is thinking about doing any kind of like social media fast or anything like that, I highly recommend it.
Yeah.
It's made a huge difference in a lot of aspects of my life, more than just I don't know, mental health even. I mean, I think I'm sleeping better, which I guess it all ties together or whatever. But I don't know. It's like getting rid of that distraction has, I'm a lot happier with the work I'm doing, and everything. I just feel able to concentrate so much more. Like there's not this like nagging sense of doom looming behind me all the time. I think it's the biggest thing.
Hey, thanks for coming on the show and updating us on what David Amos has been up to. It's been fantastic to talk to you again.
Yeah, for sure. Thanks for inviting me.
All right. Yeah, talk to you soon.
All right. See you, man.
And don't forget, installing Sentry is simple, like 5 lines of code simple. Use the code REALPython during signup, and new users get 3 free months of the team plan. So when your code breaks, you can fix it fast with Sentry. I want to thank David Amos for coming back on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.